Good morning, everyone. For the DBMS subject, today we will begin with a new topic of the third unit, the last topic, which is called as ER model, entity relationship model to relational mapping. Which means now we have learned how to create the tables, then how to create the attributes, and what kind of attribute it is, whether it is a primary key or whether it is foreign key. So this respective table, a single table, we are supposed to find how the relationship is getting work out with other tables. When we say about the database, we only don't think about one table. We will be having more number of tables here. So those more number of tables, how they have connected with each other, what kind of a relationship is there, that relationship we have to take, and we are supposed to build a relation schema here. The mapping means what we have learned at the starting first unit. The mapping was called as this what relationship here, how we are going to jump from one table to another table, and what kind of a relationship is there between those entities or those tables here. So let me start sharing the screen, what the topic exactly it is. Hope the screen is visible for you people. I'll just go starting part. It's very kind of tough, but we will cover up very fast here. So the topic name for the third unit is Relational Database Design by Entity Relationship to Relational Mapping here. So here, relational database. Already database is available with us. This what for the ER diagram. We have the ER diagram. I hope you have drawn the ER diagram for your company database here. So that ER diagram, relational database design by entity relationship to relational mapping here. Whatever the ER diagram is being present with us, that ER diagram we are supposed to take, and we are supposed to create a separate table entities, find out what are the attributes for that, and what will be the primary key, what will be the foreign key here, and how the relationship is getting built here. So the relationship also we have worked like a cardinality ratios, that is 1:1, 1:n, 1:many, or many is to n here. That kind of a relationship we have learned here. It is not that difficult, but we have to think already the ER diagram is available. Convert that ER diagram to the relational schema here. What exactly the schema it is? What is nothing but the group of attributes being present in one table here. So that we are supposed to define. So for the examination, the question will arise for this every year. Not every year, I cannot say that, but the question will arise for 10 marks at least, including your diagram and relational schema here. So they may ask the question, explain the different steps for ER to relational mapping here, or relational database designed by ER to relational mapping here. So there are complete 7 steps for mapping ER diagram to relational database here. Completely ER diagram is available with this, which will be displayed for your next slide. The company database itself, that ER diagram you are supposed to convert to the relational database here. How you are going to identify the table? Based on that table, what are the attributes that you have to create a database with what ER diagram here. So those are 7 steps. The first step represents the mapping of regular entities. We can call it as a strong entities also here. So we'll be working for separate here. Regular entities, normal entities here. So step 2 considers mapping of weak entity types here. Which are the weak entities? Before that, proceeding for the regular entity types or weak entity types, we should know what exactly the definition for the regular entity and weak entity. What does it mean? Okay, so that we are supposed to be aware, and so we can look forward for the next steps. Then the step 3 represents your mapping of binary. The binary represents the 2 ways here. What 2 ways it is there here of how many tables we are supposed to take here. So binary represents 2 way, representing mapping of binary 1:1, like one way. getting from each table, one value should be represented here. So 1:1 relationship types here. You are supposed to identify which all tables are having the relationship called as a 1:1 here. Okay. So example, you can remember for the 1:1 as a student has one Aadhaar card number, student has one university number here. So that also is student and university tables are there. So between these two, 1:1 relationship will be created. So for this, you are supposed to check out what will be the 1:1 relationship for your company database here. Okay. Coming to the step fourth one, mapping of binary. Again, like a two tables are there. Here we are going to work for the two tables relationship only. 1:n relationship here. Like example, I can say one student has opted for n number of courses here. Take an example as a Renuka has taken Java, Advanced Java Database Management System, that Python and Android. So like 1:n here. Many students have many phone numbers, we can call it that also. Many students have many account numbers, bank account numbers, so that also here. So in that company database, which table or which entity is going to get represented as 1:n relationship types here. Moving to the step 5, mapping of binary. As I have told you that binary is coming only for the two tables. M:(n) relationship types. From both the tables, the participation has become more number of types here. Okay, more number of times here, the participation has become more number of times here. More students have opted for more number of courses here. Then going for the step 6, mapping of multi-valued attributes here. Now coming to the point of the multi-valued attributes, we should know what exactly the multi-valued attributes here. Before proceeding for the multi-valued attributes, we should remember what is the attribute here. It is nothing but the property of the entity or schema here. So I say that whenever you purchase anything from the Amazon shop, Amazon.com or any other, so they will be asking for you people alternative phone number here. Currently, you see no vaccination drive also was there here. They were asking for the two phone numbers, alternate phone numbers. So that two phone numbers of respective same person has, we call it as what multi-valued attributes here. So coming to this topic for the ER diagram of the company database, you are supposed to identify which will become as a multi-valued attribute and what it has to be done with that multi-valued attribute here. Okay. And then that multi-valued attribute also going to work at the relationship afterwards. And moving to the towards the last step 7, which is called as a mapping of enry relationship types here. Like here we have worked for the binary, right? So two tables are going to work out, or two entities are going to work out. But here what happens, it is that mapping of enry relationships here. Like three tables or four tables are getting participated in one relationship here. Yeah. As of now, we have worked two tables in one relationship here. But here, what is happening? Four tables, five tables, or five entities are working for the same relationship here. Okay. So moving for the step by step, what exactly the step 1 specifies, step 2. Let us work out. I'll go for the next slide. Yeah. Yes. Before proceeding for those steps, work out slowly, not in a hurry. Yes. Coming to this point here, this is the ER diagram. So now this entire ER diagram, what we have to do is that we are supposed to convert to the schema or relational database. With the help of this diagram, we are supposed to create the database. Right? So proceeding for this, we have learned the different ER diagram notations here. Rectangle represents your entity. Then after that, relationship represents your diamond or Roman shape here. And coming to the point here, when you have a single rectangle or single box here, we call it as a regular entity or a strong entity. When you people have the double rectangle or double square box, we call it as what? Weak entity. Now, what exactly weak entity and what is a strong entity? Just in a basic way or in a short way, strong entity is an entity which is having a primary key. And coming to the weak entity is nothing, just vice versa of the strong entity, which means that weak entity don't have any primary key. Okay. Then after that, here also you can see the relationship also have been created in a single diamond shape or single rhombus, which means that strong relationship. And when you people have the double rhombus, double line diamond here, we call it as what? Weak relationship. Okay. And the oval shape, which are called as these are the attributes here. And whichever the attributes are getting represented underlined, we call it as a primary key here. And coming to this point here, name, the attribute which is called as a name, again it is getting classified. We will call it as what? Composite attributes here. It's getting classified. We will call it as a composite attributes here. And after that, here for this is the employee table. For the employee table, social security number is a this what the primary key. And after that, for the department, just to inform you, just to remind you here, the name which is being underlined, as I have now told that wherever the attribute for the oval shape is getting underlined, we call it as a primary key. But the printing mistake for the textbook also is being done as a name is not a primary key. By mistake they have done. For the department table, number is a primary key, and same for the project table also. Name is not the primary key here. The mistake has been created from the textbook itself. So you might get confusion when it is underlined and why it is not the primary here. So for your reference sake, for your kind information, I have told that the department, the name attribute is not a primary key. Similarly, for the project table, name is not a primary key. It is normal attribute here. Okay. And here you can check what the location is here. Just a minute. Yeah, coming to this point here, the oval circle, which is a double oval here, we call it as what? Multi-valued attributes. So what is to be done with this multi-valued attributes, where we are supposed to include? So that also will work out in the this what ER to relational mapping here. Okay. Then after that, one more thing for the ER diagram. You people can see the relationship. I mean entity, and here is the relationship. You people can have a look here. There is a single line you can see here, and here it is a double line. So these lines which are getting represented as a double line and single line, we have to remember the concept which is called as a participation, right? Participation means what? One entity's value. I mean entity's value or some information, some data is getting participated in relationship here. Like, okay, similarly, as for this information, this topic, we are working for the binary relationship where when two entities are getting connected with the one relationship. Here you can see employee with works for and getting connected with the department table. So binary has been worked here. So how it is getting participated? Either total participation or either is a partial participation. Working to the point which is called as a total participation, we say that total participation is when from the entities, all the values are getting participated in relationship. All the values, all the values are getting participated in a relationship. We will call it as a total participation, and it is getting represented by double line. When we say that is a double line, we have to remember that it is completely total participation. When from the entity to the relationship, you people have a double line, we will say that it is a total participation here. And coming to the next point, when you have a single line from the entity to the relationship, now here people can have a look here. This is the employee table, and the managers is what relationship here. So employee to manages. Here we are representing the single line. So we have to say that this is a partial participation. What exactly partial participation is that here? Vice versa of the total participation. Again, go back to the total participation. The total participation is that from the entity, and all the values are participating. None of the values are empty. None of the values are idle. I mean, some it is getting participated here. So coming to the point of the partial participation from the entity, from all that values, any of the values or only one value is getting participated in this what relationship, that time we will say it as a partial. Means what? Not all values participating in that relationship here. Only some values are getting participated in relationship. Okay, as I had told you my example, when my entire class gives me response when I ask the question, that time I will say total participation. And when the entire class is present, but only few students will answer my question, that time I will say it is a partial participation. Okay. So partial participation is getting represented with single line. Total participation is getting represented with a double line here. Okay. Now, moving to this concept with this ER diagram, we will find out what are the entities here. Employee table is there, dependent table is there, project table, department table is there. Okay, so we will take this table and we will start working for the steps here, which is there for the ER to relational mapping. So step by step. So total 7 steps are there. Moving forward to your first step. So mapping of regular entity types here. Now, regular entity types or normal entity types, what we say as a strong entity here. So let us have a look here step by step. So here, proceeding for this, entity means what? It is a table. It is a relation here. A table which has attributes, we will call it as a relation here. So what they have said, mapping of regular entities. Find out which all tables are there in your ER diagram and how they are working. And only find out which are the strong entities. I mean, not weak entities here. So here, for each regular entity, in a bracket, they have provided a strong entity type E. Normal name, you can give here type E. In the entity relationship schema, it is what consists of the attributes, the normal single line you are supposed to draw. Create a relation R that includes all the simple attributes or simple components of composite attributes of E here. So what does it mean here? Whatever your relation is there, whatever your table is there, that table or that entity attributes are getting presented, include that attributes also. First of all, include all those attributes here from the normal entity and choose one of the key attributes of that relation or E as the primary key of the relation here. So now one table is there. Assume that your regular example student table is present here. In that student table or in that student entity, we have the attributes which is called as a, now simple attributes I will say. Simple attributes I will say, wait, I'll just annotate here some information for you. I will say student attribute is present. I'll go for the text. Now I'll say the student table is present here. For the student table, pardon me for the spelling. For the student table, we are going to take roll number, name, then phone number, and address. Okay. So this is the student table or student entity, and these are my normal attributes here, which is called as the roll number, name, phone, and address here. Okay. So first point is done. For each regular or strong entity in the ER schema, create a relation R that includes all the simple attributes or simple components of composite attributes. Now coming to the second point, choose one of the key attributes of this schema as the primary key. So from this, all the attributes which are roll number, name, phone number, address, please make one key as a primary key, which can be uniquely identified. Now, roll number, yeah, I can identify here. Name, I cannot provide it as a primary key. Why? Because we can have Aishwaryas, we can have n number of Aishwaryas will be there. So for that, we cannot provide it. Phone number also cannot be done because this is a very complicated to remember here. And address also, what happens for the address also, n number of people will stay at the same address. For that purpose, you cannot make this address also as a primary key. Okay, coming, so from this table we can make the relation primary key as a roll number here, which is the unique key and which is not being repeated here. Then if the chosen key of E is composite, composite means what are the composite attributes here? Now for this address, we can make it as a composite address here or attribute. What is actually the composite attribute is that when we classify that attribute again in ways here. Now address can be classified as a street number, city, state, right? So the way you have seen for the ER diagram previously for the complete database, name. So that name is getting worked as a composite attributes as a F name, which is the first name, then a middle initial name, then after that last name. Okay. So these also, if the chosen key of E is composite, if suppose a name is going to become as a primary key, the set of simple attributes that will form it will together form the key of it will together form the primary key of RL. So if you are going to make this as a this what primary key, you cannot make the first name, middle initial name, and the last name here again the primary key. Only name can be worked as a primary key. Okay. So for this also, you cannot make again F name is also primary key, middle initial also is the primary key, and last name also it's no. So this together you are supposed to make single primary key. If the case arises, right now that case is not available as a name, we cannot make it as a primary key. What happens because Aishwaryas will be having same Aishwaryas. Some Aishwarya will be Aishwarya Patil, one Aishwarya Patil, another again Aishwarya Patil. So you will get confused, right? For that purpose, we cannot make this here. In case if you work out for the composite attribute, no need of making the classified attributes of that composite attributes as a primary key. No, only make it as a one. Okay. So coming to our example, we create the relations employee, department, project in the relation schema corresponding to the regular entities in the ER diagram here. Okay, so from that ER diagram, we are supposed to identify which are the regular entities or strong entities. Your first step specifies that strong entity means what, which is having a primary key. So three tables are being created for this: employee table, department table, and project table in the relational schema corresponding to the regular entities in the ER diagram here. And from this table, employee table, department table, and project table, you are supposed to identify one attribute which is called as a primary key here, which can be identified uniquely, which cannot be repeated here. So SSN is what social security number is getting represented for the employee table, which will become primary key. Then D number, which we call it as a department number, will be the primary key for the entity or for the table called as a department table. And P number, which is a project number, which is going to be the primary key for the entity or the table, which is called as the project. So here they have said social security number referred as a SSN, department number, project number are the primary keys for the relations employee, department, and project as shown in the next slide. So we'll go for the next slide. I'll go for the next diagram. Next slide. Wait, slowly. So here is a ER diagram presented. mapping of regular entities, which we are in a step 1 for the ER2 relational database schema here. Mapping it is there here. So from that we have been identified the 3 entities: employee entity or employee table, department entity or department table, and the project entity or the project table. We are identifying what strong entity. And one more table is there here, dependent, but this will not become the regular or a strong entity, as it is representing the weak entity here. Okay, so now from this employee table, we are supposed to find out the attributes first of all. So let us work here. Social security number, then birth date, then name. Where is mouse? Name, then sex, address, salary. So these are the attributes are getting presented. From these attributes, social security number can be made as a primary key, which can be identified uniquely here without any repetition. So employee table has a social security number as a primary key. Coming to the next table, department table, please consider that the name is being underlined in your textbook diagram, but that is not a primary key. I will repeat, the name is being underlined in your textbook, but that is not a primary key. The printing mistake has been occurred. Okay. So for the department entity or the table, we have the attributes which is called as a name, number, locations here. So 2 regular attributes are there, and 1 location attribute. It is double oval, which we will call it as multi-valued attributes here. So from these 3 attributes, name, number, locations, 1 attribute has to be made as a primary key. So we are going to consider the number as a primary key here. Cannot consider the name, because HR departments can be 2, right? 2 HR will be there, but we will get confused which HR here. So for that, we have to give the number here as a unique value, which will be not repeated here. Coming to the last entity or a table, which was included for your previous slide, that was a project. Again, I will repeat, here the name is being underlined from your textbook. It is not a primary key. Just remember. So 3 attributes are there for this entity or a table, which are name, number, and location here. So from this, you are supposed to make one of the attributes which is called as a primary key. So for this also, we are going to make it as a number as a primary key. So now you might be wondering, in the department table also number is a primary key, and in your project table is also number is a primary key. Not to worry or not to bother about this. Entities can have the same attribute names here, but no same entity should be there. Okay. Now you see, no, for your first semester you have roll number. Immediately for your second semester also roll number is there. We cannot say that for first semester roll number is being given, we have to change the name of that attribute. No, it is not. Important thing is what entity attributes can be same for the different entities here. Okay. So here the number we are going to make it as a primary key, which is uniquely identified and not repeated here. And the location is one more time. So from your first step, which we are mapping for the regular entities, so we have done the 3 tables or 3 entities, that is employee, project table, and department table. And from this table, every entity has a single primary key. For the employee, we have considered the primary key as social security number. For the department table, we have considered as a D number. As a department number, which is called as a primary key. And lastly, for the project entity or the table, we have considered the number or project number as a primary key. So here is the schema diagram. See, so for that ER diagram, we are supposed to identify the tables, as I have told you that rectangle, which we will say as a table. So employee is a table, right? In this employee table, F name, init name, last name. So this is what complete combination or single thing we have to include. You see, so these all, it is not. So these all 3 things, F name, middle initial name, last name, will become a single attribute which is called as a name. Okay. we are actually working for what primary keys here. So social security number is a primary key, then birth date is a normal key, address is a normal key, sex, salary, and let us not consider this super SSN and department number. Let us keep it aside. Let us keep that aside here. Let us not consider. We will consider only till here. Okay. These all the things here. Then coming to the department table, for the department table, we have department name attribute and department number here. Sufficient. Let us not consider this timing. We will keep it aside. And one more table which is called as a project table. From the project table, we have project name as an attribute and project number and location also there. So project number we are going to make it as a primary key. So for the employee key, SSN is a primary key. Okay. And for the department table, D number is a primary key here. And for the project table, project number is a primary key. Okay. Yeah. So this is done here. And you might be thinking department, location, works on, dependent. Okay. So that are also table also available here. Only what we have to go on checking what all attributes are present here. But main focus is given on this what regular entities or strong entity types. So what you have to remember for your first step, just you are supposed to identify the regular entities, which is a single rectangle, single line rectangle, and from that rectangle line you have to check out which are the primary keys here. Okay, so from this diagram or from this example, we have three tables, which is the employee table. For this, we are having the social security number as a primary key, and the next entity is called as a department table. For this department table, we are considering department number as a primary key, and another table is called as a project table. For this, we are going to consider the project number as a primary key. So we have to remember this. Okay. Coming to the next slide. Coming to the next slide here. So coming to this next step, which is called as a mapping of weak entities. The first step is done, which we were identifying the regular strong entities. So we have received what are the strong entities. So from that table, strong entities was employee table, and after that, which one project table and department table. Now, similarly, we have to identify which are the weak entities here. So directly, I will work for the diagram. First of all, you should understand what is a weak entity. Weak entity is nothing but that entity or that relation or that table which do not have the primary key. That we will say it as a weak entity here. Now, from this ER diagram, how we are going to identify or how we are going to represent your weak entity here. So let us see. For each weak entity type W, you can give any name here. In the ER schema with owner entity type E, create relation R and include all the simple attributes or simple components and composite attributes of W as the attribute of R. So whatever I read this or whatever you read this will get confused here. So better what we do, we will go for the diagram and I'll tell you how it will work for your mapping of weak entities here. Okay. I'll just go for the diagram here for the main diagram. So see, hope this is visible for you people. We'll work for the annotate. Okay. What are the strong entities? Employee is a strong entity, department is a strong entity, project is a strong entity. Now, how to identify the weak entity? First of all, definition is what weak entity which do not have the primary key here. So that we will call it as a weak entity. Okay. And strong entity is what? Which will have the primary key. Okay. So now from this, and how it is getting represented with the double rectangle. Okay. So here we can identify, please cooperate for my drawing. Uh, we can identify from this diagram the double rectangle which is called as a dependent. So this dependent, we can make it as a what? Weak entity here. Okay. Now what is to be done with this weak entity? Okay, and they have said that whenever you are going to identify the entity, compulsory you have to make that entity one attribute as a primary key. Now the question arises here. For the weak entity, there is a no primary key. How you are going to identify that? In that case, how you are supposed to build the relationship and how you are going to make it. So what we have to do is that what they have said, you can have a look at the slide here. See, for each weak entity W in the ER schema with the owner entity type E, create a relation R, include all the simple attributes of W as attributes of R. Okay, so these two things are there. Yes, include as a foreign key attributes of R in the primary key attributes of security number, dependent name. So let us go back. First, dependent name. Here, how you are going to identify from the weak entity primary key, how you are going to make that. Weak entity will not have the primary key. So what they have said that consider one of the weak entity. Now from this table weak entity we have done, and this is the relationship which is called as a dependence of, and another relationship you can have a look here for the employee to dependent. There is a relationship which is called as a employee and dependent here. Now, from this employee table, you are supposed to consider the social security number, right? So, which is a primary key. So, from this dependent table, can you make the name as a primary key? No. Aishwarya's will be a number of Aishwarya's will be there. Sex we can make female male. No, it is getting repeated, right? Birth rate. Of course, some students or some employees will have the same birth rate. Relationship. Yes, sisters, brothers, anything which is getting repeated here. So we cannot make any of the primary keys. But how? Still how it can be built it is that we are supposed to make from this attribute as a partial key. Still, which can happen, which can identify. So from the gender, we cannot say that female, male. The birthday, no, तिचा पण birthday इथंच आहे, तसंच आहे, we say. Relationship, she is a sister, even I am a sister, no. But with the help of name, we can make it as a kind of partial key, no. Not complete. This Aishwarya's sister, this Aishwarya's brother here, I can say that. So, which is being underlined here, dashed underline, this we have to make as a partial key. So what this step actually says, let me draw and show here. Okay, let me give the idea for exactly. So owner entity, they had said that owner entity. Now which is the owner entity? Employee is going to be the owner entity, and weak entity it is what? Dependent is going to be the weak entity. So from this owner entities, you have to include the primary key, which is called as a social security number, and plus from the weak entity, which is a weak entity, partial key has to be included. What is a partial key? Still, we can make that as a primary key to identify the values here. Name, still we can make it. Actually, completely it is not a primary key, but we can make it as a partial key. So these together, primary key of the owner entity, which is employee, and partial key of this weak entity, together will become this what? Primary key here. Together it will become the primary key here. I will repeat, owner entity is the employee. From this owner entity employee table, consider social security number as a primary key, and from this weak entity table, which is a dependent, consider name as a partial key. So primary key plus partial key will become a primary key for this weak entity, which is called as a dependent table. How it will become, how it is getting described, let us go to the slide here. Will clear all my drawings here. Also include as a foreign key attribute of relation the primary key attributes of the relation that correspond to the owner entity type. The primary key of relation R is a combination of the primary keys of the owners and the partial key of the weak entity W if any. So employee social security number is a primary key and the partial key of the dependent is what name will become completely as a primary key. So now let us see a description. Create the relation which is called as a dependent in this step to correspond to the weak entity type dependent. So dependent is going to be the weak entity, right? Include the primary key social security number of the employee relation as a foreign key attribute of this what dependent which has become renamed to the social security. हमने name partial key रखा है, but how you are supposed to identify name also still. So the primary key of the dependent will become the relation is the combination of the social security number and this what dependent name here. We cannot identify dependent name. That is a partial key, but still we cannot make that completely as a primary key. I said that which Aishwarya, this Aishwarya or that Aishwarya. So because the dependent name is the partial key of the dependent. So identify actually what relation or how we are going to check here. We have to consider the combination of the primary key of the owner entity and partial key of the big entity here. Okay. So here for the ER schema diagram, which is being displayed here. Employee table. Now here employee table, you people have a social security number, which is employee table, which has a social security number as a primary key, and this primary key will become as a foreign key for the dependent table. Here you can have a look here. Yes, in that dependent ER diagram, we are not having any primary key, but we have to consider this as a foreign key for the dependent table, and here name is going to be the partial key. So together this is social security number and name is going to become as a primary key for this dependent table, which is called as a weak entity. And you can have a look here where here the name is being attribute name is different, but the values are getting referred from the master table, which is called as the employee table here. So you can have this line is going towards the social security, which means that this social security number is acquiring the values of the employee table. So these was the two steps we have completed as of today. So I'll make still two steps table in the next video. Till then, have a look for this two steps here. The third step will be proceed for the next video. Thank you.